My name is Marta Sokół, and today I would like to present the results of my the aforementioned master's thesis, which was submitted to the Institute of Cognitive Science at Osnabrück University. Within the thesis, I would like to, I focused on investigating the subjective time perception or the temporal experience in BPD patients using deep learning and natural language processing. I would like to begin with a statement, which is actually quite well recognized within the discipline of BPD and lived time, that it is well known that time experience in BPD is altered, and we know that we can know that from basing on evidence from numerous research spanning over more experimental and phenomenological disciplines. And within this current research, I focused on three most relevant concepts involving instantaneity, immediacy, and cyclicity. So even though they were formally introduced yesterday by Anna, during her presentation, I would like to recap those concepts. So instantaneity involves the perception of experiences and emotions as occurring in rapid succession, creating a sense of constant urgency and fleeting moments. It mostly emphasizes the fragmentation, the disjoint nature of the time experienced in BPD patients. Immediacy is a similar concept in that it also refers to the present orientedness of these patients. It refers to the intense focus on the overwhelming experience on of the present moment, which often leads to impulsive actions and a fragmented sense of time. But it's mostly focused on the active engagement with the present. And cyclicity is a bit of a different concept, but it describes the temporal experience of individuals with BPD as being governed by some repetitive ahistorical oscillations between different, usually very strong emotional states, such as aggression and depression. And this concept introduces a pattern of some recurring emotional turmoil and instability, creating a cyclical experience of time without historical progression. So overall, to summarize, the temporality of BPD patients is strongly present-oriented, with poor connection with the past and the future states, or the inability, at least partial, to access those states. And also it is theorized to be re-experienced in cycles. And to refer to in support of these theories, there is actually only some qualitative evidence. However, there is no really any quantitative evidence to support these claims. So this research gap essentially motivated my master's thesis, which aimed to answer the question: is BPD associated with altered lived time estimated quantitatively using phenomenological data? And by phenomenological data, I mean autobiographical corpora. So this research used phenomenological data, applied quantitative methods to, again, phenomenological concepts. So it was a hybrid approach. But as you may expect, it is quite difficult to quantify something as subjective as time experience. So that was also the first question that appeared when designing this study. And actually, to help in answering that question, I stumbled upon the concept of proxy variables, which are just essentially variables that can be used to measure another variable that is difficult to estimate. So for example, we may not be able to estimate or to measure quality of life directly, but we can certainly estimate quality of life using per capita GDP. Or maybe we can't really measure one's cognitive ability, but we can certainly use GPA to somehow estimate it. And for time experience, I assumed that it should also be possible somehow, but I initially did not know which factors could be used as proxy variables that could help in estimating time experience, especially in the case of autobiographical corpora, so in the context of language-based data. So for that, I did a literature review, which actually revealed more than 4 proxy variables, but within the scope of a master's thesis, it was possible to use 4 of them for the sake of modeling. So the first one that I found was that was correlated with time experience was valence, which is basically the pleasantness of a given word or a pleasantness of a sentence. Then I found arousal, which is actually very strongly correlated, as also mentioned in the previous talk. Also, I found word length and word frequency. And all of these factors could be used as proxy variables to help approximate time experience based on language-based data. The second question that appeared was how to extract these variables from very long texts and also more than just the one text, which would obviously be quite a difficult task to perform in the context of thousands of sentences. So this motivated the computational approach that was used within this study, because manual approaches would be definitely too cognitively and too computationally expensive, and also would be time inefficient. However, doing so, performing this research using computational methods would allow me to perform all the computations in a computational time, reducing the effort that needed to be put into the research, essentially. So 2 different approaches were used for 2 different types of variables. For the word length and word frequency computations, classical natural language processing methods were used. And for the estimation of valence and arousal, a neural network was trained on the task of sentiment analysis, which is basically just classification of sentences based on scores of valence and arousal on some scale. And for that, I searched for the books for the autobiographies that could be used within this research, and I actually found 5 of them that could be included based on these inclusion criteria. But I think I will need to rush through these slides, but we could return to them in the discussion part. And also, I matched 5 sex-matched controls. And also we might need to skip through this slide. What I did next with the obtained corpora is that they needed to be pre-processed in order to process them further with the neural network, especially with the neural network. So what I did, I needed to remove all the special characters, maybe multiple spaces, and essentially put them into a tabular data structure known as a data frame, wherein each sentence was put into a separate row. And each file corresponded to one single corpus. So there were 10 files, 5 for each experimental group. And the chronological order was preserved. Chronological order of sentences was preserved in each such file. What happened next is that I needed to create another data set, which was completely unrelated to the data set of corpora, which I needed for the training of a neural network, because the neural network had needed to obtain some examples to learn, to learn how to classify sentiments. And for that, I initially wanted to use a data set of over 700 sentences, which were classified on the base or rated on the basis of sentiments, both valence and arousal. However, this turned out to not be enough for the current analysis, and also these sentences did not include the specificities of borderline personality disorder and the experience of having BPD. So they did not have any sentences that would relate to, for example, being in a psychiatric ward, or maybe different types of experiences related to having BPD. So because of that, I found one additional autobiography written by a BPD patient. So it was a sixth one that was not used for the current analysis. And from that, I extracted over 900 sentences, which were then rated by three experts, by Anna and by Professor Moskalevich and I. And we rated them on a scale from 0 to 2, so 0, 1, 2, for valence and arousal. And having obtained this data set, I merged them together with the previously mentioned data sets, normalized the data, and with that I obtained the total data set size of 1,638 sentences, which was quite large. So having obtained the training data set, I could finally begin the process of training the network. For the training, I used a pre-trained model, which is essentially a model that is, as a standalone, it can be used as a large language model. However, when you add specialized layers on top of it, it can perform many different roles. In this case, I fine-tuned a model, so I added these layers for the task of sentiment analysis, so that it would classify each sentence on the basis of arousal and valence. And the resulting accuracy of the model was actually quite good, and quite comparable to the inter-rater agreement that I computed for the training data sets that we annotated. So this is the only benchmark that we could use in this study, because these results are not really comparable with any other benchmarks outside of this context. So it can be deemed as a pretty good performance. So having completed all of these steps, I already had the valence and arousal for each sentence, and here you can see two examples of two sentences that were extracted and translated from, I think, one corpus of a BPD patient. But what was still missing is that there was still no, at this point, I still had no values for word length and word frequency. And these were actually quite straightforward to compute. However, these were quite straightforward to compute, and there were the resulting, as a result, I obtained three different categories: short words, average words, and long words. And for that, I used a criterion of 5%, which is arbitrary, actually, and probably could be chosen to be different. However, for the sake of modeling, I had to use one such criterion, and I decided to use 5% of the bottom probability distribution and 5% of the upper probability distribution in order to classify the words as either short or long, or frequent and infrequent. And the remaining 90% of words from the probability distribution were classified as just average. Up until this point, I already obtained the values for valence, arousal, word length, and word frequency. However, that still didn't inform me as to how these results translated into the actual time experience. So what effect these values would have on time experience. And for that, I used effect sizes, which are a known measure of the magnitude of the association between two variables. So essentially, they quantify the strength of the association between two variables. And I used them to somehow quantify the effect that I was interested in. And I substituted them for these previously obtained values. And as a result, and then I summed them. And the final result is the one you can see in the red bracket, red square, rectangle. And this is the final effect size or the final parameter, which was then plotted onto a time series of time experience. Time series is simply a graph of some events in time. And in this case, you can see on this graph, you can see one corpus obtained from one patient, one BPD patient. On the x-axis, you can see the sentence indices. So these are just chronologically ordered sentences, and they're indices actually. On the y-axis, you can see the values of the parameters that I have just described. And they are given in effect sizes, or actually in the unit of Hedges G. With the red arrow, which points towards like gray spikes, you can see the exact value that I have just shown you. And importantly, towards the top of the graph, you can see that the values that are closer towards the top of the graph indicate temporal underestimation, while the values pointing towards or closer towards the bottom of the graph are indicative of temporal overestimation. And perhaps you can see that the gray values, the gray spikes, are quite disjoint, and they do not really indicate any concrete trend, as you would expect with time perception, which probably doesn't fluctuate as much. And also, it doesn't take into account that time experience is continuous and not completely disjoint. So because of that, I applied a state estimation algorithm, which essentially can make these measurements more continuous, can also reveal the trend of the data. And for that, I used exponential moving average, which is a pretty straightforward algorithm. And with that, I obtained the blue result, which is perhaps the easiest way to conceptualize time experience within time experience on this graph for a single patient across the time expressed in sentences. So this is the blue line. And as an interesting fact, to somehow connect back into the qualitative analysis and phenomenological methods, I would like to show how I would like to show that actually all of these different behaviors of the data correspond to different events that took place within the corpus. For example, the first radical increase corresponds to the admission to the ER unit after a suicide attempt by the author. The second one to the realization of unwanted pregnancy. The third one I think is really interesting because the author wrote, I don't think, I don't feel, I don't speak, I don't hear, I don't see, I am not here, I don't exist. And the final one is also quite interesting because it signified, or it corresponded with, to the end of a romantic relationship of the author. But coming back to the quantitative and also the final results of the study, I still needed to compare the control group and the BPD group, and for that I needed quantitative measures, and one of them was autocorrelation, which I used autocorrelation with lag 1, which means that for each state, let's say state 3, sentence 3, I correlated the previous state, and the previous state, the state 2, I correlated with state 1, and I did that for all the states. So essentially correlated the data with the lagged version of the data. And that allowed me to see, to investigate the short-term predictability of time experience. So I did that. And also another measure, which is a bit more sophisticated, is actually the sample entropy algorithm, which is capable of capturing a bit more long-term, more sophisticated trends in the data. So, for example, it could examine the predictability that is based in some oscillations, maybe some repetitive long-term patterns. So this was used as a long-term predictability measure of the future. So I did that, and I compared the control group versus the BPD group. And as a result, the autocorrelation with lag 1, when compared between the control and the BPD group, resulted in a significant result. There was a significant difference, wherein the control group was characterized by higher autocorrelation, indicating more consistent, more predictable short-term patterns of time experience. And if we compare sample entropy, after comparing sample entropy between the control group and the BPD group, the results were quite staggering, because the p-value was extremely low, indicating a very highly significant relationship. And interestingly, as a result, it was revealed that actually the mean of the control group was much higher, indicating higher unpredictability of the control group. And actually, the BPD group was found to be much more predictable long-term. So it essentially points to an interesting observation that overall the temporality of BPD patients, at least as measured quantitatively, is more unpredictable short-term, but somehow more predictable long-term. So this could indicate high short-term variability, but overall long-term, this could imply, for example, oscillations or different types of predictable long-term phenomena. So to conclude, time experience in BPD individuals is altered, and that is confirmed by prior phenomenological and non-phenomenal and experimental studies. And the results of this study suggest that time experience in BPD individuals is probably repetitive, because it is highly short-term variable, but not very, but very predictable long-term. So it could have predictable motifs and high short-term temporal variability. And this seems to confirm the concepts of immediacy, instantaneity, and possibly cyclicity, although that would have to be further confirmed by additional analysis, such as Fourier analysis, for example, and would of course need to be followed up by perhaps larger samples, because the current sample was quite small. And the implications of this research are involve better understanding of time perception in BPD individuals, perhaps diagnostic and therapeutic successes, also enrichment of phenomenological theories with quantitative evidence, and hopefully maybe it will serve as an inspiration for further interdisciplinary research. Thank you.